solve the problem is word count in a MapReduce programming. So what is the word count exactly first? What is the word count problem? So the problem is whenever some people are given like a text file to you, in the text file you will be having some text content will be there. Just extract that content out of that unique words. What are the unique words are there, and the corresponding unique word like is how many times it is occurred in multiple places. That is the count. So we're extracting the unique word and corresponding count. This is what we are calling as a word count. This is a basic problem in the MapReduce. Just when you go for like a C, C++, Java, we will write a hello world program. As equivalent to the Hadoop is the word count. So we are going to see the basic concepts of what is word count and how to solve it. The problem is given a text file, we should be able to extract the unique words and corresponding word occurrences. So that is what the count. Now let's understand in terms of some example. So this is one example for how exactly word count is going to be working. So this is the input I am giving it. So I am having a text file with the 4 lines. The first line contain I am going, second line contain to Hyderabad, third line contain I am learning, fourth line contain Hadoop course. So now we need to process this entire file using the MapReduce. Once we process this, we are going to get an output. What is the expected output is I 2 times, am 2 times, course 1 time, going 1 time, Hadoop 1 time, learning 1 time. So 2 Hyderabad. So they are all coming in a 1 time. So this is what the expected output when we execute this one. So this is how we can possible to solve it. We need to understand. The problem is given a text file like this. What are the unique words are there? We should be able to paste it, and the corresponding the word how many times occurred. We need to place the count. That is what the word count problem. I think hope you understand the problem. So now let's go for the next slide. How to solve this problem using the MapReduce. So using the MapReduce we can solve this problem very easily and very efficiently. Why? Because MapReduce is a functional programming model. It should do the distributed parallel processing. That means when you have a large amount of data also, it won't take much time. So what are the benchmarks are people are given at the time of 2000 Chinese 1 TB data using the MapReduce. They solve it over only 62 seconds. That means there is n number of machines they have it, all those machines, it's run the program parallelly and it is execute the results. With the commodity hardware machines also, we can always get a best results with the help of Hadoop MapReduce framework. That is the goal for Hadoop MapReduce. And how exactly this problem we can solve it. So whenever you want to solve this problem using the MapReduce, you should clear 2 concepts in the MapReduce. One is mapper, another one is reducer. But what is mapper and what is reducer? Mapper will simply extract the data from your input file with the help of a concept called input format. So here you need to understand what is the default input format is text input format. Just remember that one. Most frequently these questions will be there in the interview. And similarly there is a reducer. So the reducer will give the aggregate data from the mapper output. What are the mapper output we have it will going to give it, and after that it will send that data to the output format. What is the default output format is? The answer will be text output format. So make sure that just understand the basics about the mapper and reducer. Mapper will extract the data from an input file and will do some kind of processing. The reducer will aggregate the data from a mapper and send it to the output format. This is what the general view of this problem if you want to solve it. So let's go somewhat one more level down. So this is the basic flow of MapReduce if you want to solve any problem. So given an input, you want to get an output, means the MapReduce will follow these steps. So what is the first step is, given an input, it will convert into a key and values. The first one who will be taking care of that one is input format. The responsibility of the input format is given an input, it will convert into a key and values. That's what we can say like a key 1, value 1. And whatever the key and value we got it, this again will be converted into a one more key and value that is called as a K2 V2. Who will take care of this one is there is a concept called mapper. And again this K2 V2 it's again converting into a K2 list of V2. Who will take care of this one is there is a concept called shuffle and sort. And again this K2 list of V2 who will convert into K3 V3 is there is a concept called reducer. And finally we will take care of K3 V3 into your output is your output format. So these are the basic keywords. First everyone has to be clear. So what are the keywords are involved here? Key and values, and input and output, and as well as input format, output format, mapper, reduce, shuffle and short. So what exactly the input format responsibility? It will read the file with the help of record reader. There is an internal concept called record reader. With the help of your record reader, your input file will read the input format and it will convert into that input file into n number of records. Those records will pass it to the mapper class. So the mapper class will having internally one method called map method. That is what we generally call it as in functional programming function. So map reduce, map is a one function, reduce is a one function. So this is the reason we'll call map reduce is a functional programming model. It's a functional is the one function is mapper, map other function is reduce. So this map reduce will give an option to you distributed parallel processing. Where the parallel processing is there, the map reduces, mappers will run parallelly. When you have an input file is very large, like a terabytes and petabytes and exabytes, depends on the, your input file, depends on the, your input split file will be going to split like a n number of splits. So when you store the data into HDFS, it will come as a concept called block. But the same thing when you go for the map reduce, you'll be having a concept called input split. So how many splits will be, how many blocks will be there, those many splits will be there by default. So that means if I have a file with the 1 GB and my block size is 64 MB, then I'll be having a 16 blocks. So by default number of blocks is equal to number of splits. That means I will be having for the program is 16 mappers are going to be executed. So that's what the basic part everyone has to be clear. So whenever you got n number of splits, all these splits will go internally with the concept called input format. So this input format will get all the splits and will pass it to the record reader. That record reader will convert into a records. That records will pass it to the mapper, which a function is map function. What that map function will do is taking the record K1 V1, converting into a one more record called K2 V2. That is a map function has to taken care. And you will be having a n number of records. That means you will be getting it like n number of K2 V2s. All these K2s V2s will be going to be shuffled and sorted. The first sorting is going to happen, then corresponding duplicates, these values are going to be listed out. That means any duplicate key is there, means the corresponding values are going to coming as a list of values. And this again will send it to the one more concept called reducer. Reducer will having one function called reduce function. What this reduce function will do is converting your data K2 list of V2 into a K3 V3. And finally this K3 V3 is going to be writing as an output, that is done by the output format. So output format will use internally, there is a concept called record writer. With the help of record writer, it will write the data into the output file. So that is what the mainly the keywords involved in this flow. So once you have cleared that part, then we just need to understand like what are the framework provided keys and values to do the programming. So in Java we all see like some data types like a integer, long, double, float, boolean, null, string. These are the kind of data types we will see in the Java. Same thing it is available in the Hadoop also, some keys and values. What are the keys and values for the Hadoop is providing is for integer we will go with the Hadoop is int writable. For long, long writable. For float, float writable. Double, double writable. Boolean, boolean writable. Null writable text. Along with this, the framework is providing an option to you. You can do the customization. I want to write a Kalyan writable. I want to write a ORIENT writable. Some functionality about the Kalyan writable, some functionality ORIENT writable, maybe combination of this composite keys. All these things will be easily implementable in the Hadoop. So you want to know more information about that, you can always meet me in our ORIENIT. Okay. So now today I'm just going to tell you what are the basics here we have noted here. So there are primitive data types in the Java, and we'll be having a corresponding opposite data types in the Hadoop. I'm just mentioning here. So with the help of these things, we have to go for writing the MapReduce program. So what are the things we have to write it? Just go back to one step. So we need to make sure that what is my input file, what is my input format, and what is my k1 v1, that is the keys and values, and what could be the my mapper, and what mapper is going to generate the key and value, and what is my shuffle and sort, and what is my reducer, and what is my k3 v3 data types, and what is my output format. So all these keys and values you have to clear at the place of this one.